Our next conic shape is going to be the hyperbola. Now the hyperbola has two different equations, two possible equations. If you look at them, they look very familiar. If you look at this, you could be thinking to yourself, I saw this equation. This is the ellipse equation. We look over here. You're like, okay, again, the same. It looks like the ellipse equation. And you're right, it looks very similar to the ellipse equation, but there is one big difference, that minus sign. That is how I know the difference between a hyperbola and an ellipse. An ellipse does not have any minus signs outside of the parentheses. We do have x minus h, so there could be a negative on the top of the fraction in the parentheses being squared, but an ellipse is a positive x quantity squared and a positive y quantity squared. The hyperbola can have either the x being negative or the y being negative, and that's going to tell us about our foci and our major and minor axes that are going to come into play. So the center is still the same at hk. The r of x is still going to be our radius in the x direction, just like before. And the r of y is the radius in the y direction. And we know x goes left, right, y goes up, down. When we plot our vertices and our foci, they are always going to go on the positive axis. So with the ellipse, we had a major and a minor axis, the major being the larger radius and the minor being the smaller radius. That's not going to come into play here. For here, we're going to pay attention to which one is positive and which one is negative. The foci are going to go on the same axis as the vertices. Yesterday with the ellipses, we did the larger one squared minus the smaller one squared. For the hyperbola, we are going to add the radii squared. So you don't have to worry about which one comes first and which one goes second. You're just going to square both of them and add them together. So as I start, I'm going to immediately pay attention to where my negative is, because that's going to determine where my vertices go. So since y is positive, that tells me that the vertices and the foci go in the y direction once we get all of our pieces plotted. So the center starts off the same. We've got a positive 2, which is going to make the x-coordinate a negative 2. We've got a negative 1, which makes the y-coordinate a positive 1. The 3 is underneath the x, which means that the radius in the x direction is going to be 3. The radius in the y direction is going to be 5. Again, for our c, we said that we're going to take those values, we're going to square them, and we are going to add them together. So that gives us 9 plus 25, which is 34. That's set equal to c squared, so we have to square root each side. So c is going to be about 5.8. So let's take this information and go ahead and set up our graph. Hyperbola is going to look very different than the circle and the ellipse. We're going to start with our information at negative 2, 1. That's the center. Our r of x, we're going to go right, 1, 2, 3. I'm going to go left, 1, 2, 3. We're going to go up, 1, 2, 3, 4, 5. We're going to go down, 1, 2, 3, 4, 5. Now we're not going to connect this in a football shape. What we just did is we created a box, and that box is going to help us create our shape later. So what we're going to do is we're going to go around those points that we just created with dashed lines, because we created this imaginary box, and this box is going to help us with our shape. If you don't have a straight edge out, get one out. You can use your ID if you don't have a ruler. We're going to connect the corners, the opposite corners of the box. So we're going to go diagonally it will go through the corners and through that center. Then we're going to connect the other two corners, the top right and the bottom left. Again, if you have your ruler set up correctly, it's going to go through the corners and the center. It is important that they are going through the center to ensure that you have set up your graph correctly. So far, we have not graphed anything yet. We have graphed all of the pieces to get us to what our graph is going to look like. So from here, the vertices are going to go, we said, on the positive axis, which in this case is the y. So when I look at my graph, this is my vertex in the y direction, this is my vertex in the y direction. So these are the two vertices that we're going to have. From there, we're going to use our foci. So counting from the center, I'm going to count up 1, 2, 3, 4, 5.8. I'm going to count down from the center 1, 2, 3, 4, 5.8. The foci are always going to be, again, inside of the hyperbola. You draw your graph from the vertex. The vertex will be on the box. The foci will go inside. We use those diagonal lines as asymptotes. Our graph is approaching that line, never going to touch, never cross. It's going to help us create this shape. It looks like two parabolas, so it's going to help us create those branches. The foci points are those points that we went inside of those hyperbolas. And again, we counted 5.8 up. So if I look at that point, I'm at -2 and 6.8. When I count it down, I'm at a -2 and a -4.8. Again, the vertices are the ones that are on the box. So to help you out here, our first vertex is at a -2.6, and our second vertex is at a -2, -4. All right, one more problem, then we're done. Just like before, we now have the graph and we want to write the equation from the graph. We need to know a couple different things. Just like with the ellipse, we need to know the center, we need to know the r of x, we need to know the r of y, but we also need to know which axis is positive, because that's going to need to be determined in your equation. So we look at the center. The center is at a -2, -1. The x radius, we count 1, 2, 3, 4. We could have counted left, 1, 2, 3, 4. The r of y, we're counting up, 1, 2, 3. Now, which one is positive? The vertices always go on the positive axis. So since I see my graph, my branches of my hyperbola going in the x direction, that means that the x is going to be positive, which means we're going to have x minus h all over r of x quantity squared minus y minus k over r of y quantity squared, oops, don't know where that line came from, equals a +1. So again, because the branches are in the x direction, the x is positive, which is going to make the y negative. The center, x minus a -2, it becomes opposite, so it's a +2. The r of x is 4, quantity squared, minus y minus the y coordinate, 1, over the r of y, which is 3, quantity squared, equals 1. And that is it for the hyperbolas.